All right, good afternoon, everyone. Thanks for joining me. For those of you who don't know me, I'm David Byrne. I've been with PD Solutions, well, actually about coming up to 20 years now, pretty much since the company started. I'm based in Singapore, but frequently visit our customers in Malaysia. My role within the company, I'm manager of all of our simulation products. Now, we have many different simulation products that we cover. Obviously, this afternoon's presentation is me focusing on the Ansys products. And I would say that we've been representing Ansys for about 8 years now. And I think this is actually one of the biggest releases that we've had in the past 8 years. Now, my problem was I had about 500 pages of PowerPoint on the new features in 2023 R1, and I've tried to boil it down to about 40 pages. But I'm going to have to go through this presentation pretty quickly, so I hope you can keep up. We'll be recording it, so if I'm speaking too fast, you'll be able to slow me down on the recording. All right, so Ansys has for many years been promoting this idea of pervasive simulation, and this means using simulation throughout the design cycle, right from the initial generation of ideas, what they refer to as ideation, then through the design and analysis process, through to manufacturing, and also after the product's been manufactured, how are they actually being used? You know, how reliable are they? How are they performing within their different missions or environments? So, and this emphasis on a total solution across a wide range of physics has made Ansys by far the leading simulation software provider in the world. So in almost every area of industry, aerospace, heavy industry, consumer products, automotive, oil and gas, food and beverage, medical products, Ansys is being used by the leading companies in every sector. Now, how have they achieved this? Well, firstly, for many years now, they've had a platform generally referred to as Ansys Workbench, although it includes various other things now. And this actually provides a kind of a common environment and kind of database for many different types of simulation. On top of that, in the last few years, they've also added a very comprehensive range of materials information, because you can't actually simulate something unless you know the actual properties of the materials that you're using. And then on top of that, we have these various different sectors. We have fluids, structures, electromagnetics, semiconductors, embedded software, and more recently, optical and photonics. So we're actually doing various different types of light simulation. So it's not just the old mechanics and heat and fluids, etc. So as you can see, they now have a huge product portfolio. And obviously within the next 20-25 minutes, I'm not going to be able to cover all of these. But I just thought I'd zoom through some of them very quickly to give you an idea of some of the key features there. So firstly, in fact, the main presentation today and the main demos are going to be based on our Discovery product. Discovery actually combines a number of products that used to be. So you might say, well, this is a product collection, it's got one product. Well, it used to be 3 products. It used to be Space Claim, Discovery Live, and Discovery AIM, but those have all been now combined into a single product called Discovery. And this has multi-physics capabilities. It does structural, it does fluids, it does thermal, it does electromagnetics, it has built-in CAD modeling. So it's a very comprehensive tool, and this really provides the entry point to all of the other Ansys products. Now, Ansys has been well known for its Ansys Mechanical solver. Ansys Mechanical actually came out, well, let me see, about 50 years ago, so that was one of the early software that I was using. But over the years, they've acquired a number of other leading products, LS Dyna for dynamics, and that, in fact, is used in a new product that's just been released this year called Ansys Forming. So this is for sheet metal forming. And we also have products for mechanism dynamics, that's Ansys Motion, PCB vibration and reliability analysis, additive manufacturing solution, fatigue, and all kinds of other dynamic applications. On the fluid side, we have the very well-known Fluent solver, which is the world's #1 most widely used CFD software. But we also have other specialized software like CFX for turbo machinery, rocky for discrete elements or discontinuous materials. This could be things like gravel or rocks, or it could be pharmaceutical pills or food being, items of food being manufactured, cupcakes, whatever. So you can simulate all sorts of interesting materials. Polyflow for polymers and also for glass forming processes. And also we have advanced visualization tools like Insight. From the electronics side, we have high frequency electromagnetic simulation, low frequency electromechanical, detailed PCB, EMI, EMC, and power integrity, signal integrity, etc. And we also have IcePack for electronics thermal simulation. And all of these link together within an environment called the Ansys Electronics Desktop. So in fact, you can take any electronics product and you can simulate its mechanical, its thermal, its electromagnetic behavior, electrical behavior, all of these within one environment. I mentioned we now have these new optics products. I won't go into the details of these, but we have SPIOS, which is very advanced optical simulation, Optics Studio, which helps you design things like lenses, mirrors, prisms, reflectors, etc. And in fact, we have a special version. As you know, we're a Creo, we're the main Creo reseller, and we have a special version of Optics Studio for using Creo. So we can actually have this capability embedded within Creo. And then we have various other virtual reality, VR experience tools. So moving on, and at a very detailed level, if you're doing very high performance, photonics, things like optical integrated circuits or fiber optics or laser, things like that, then there's the Lumerical product, which was recently acquired by Ansys. And now, in addition to light, we've even got sound simulation. So we've got Ansys acoustic simulation. This can determine the quality of sound within different environments. Could be in a car or a concert hall or things like that. We have our material system that's a materials database, but also can actually help you choose appropriate materials for your application. And also, if you're generating your own materials information, that can be saved into the grant and materials information database. And connecting all of these together, we have the Workbench product I mentioned earlier, but we also have tools for model-based systems engineering, simulation data management, and multi-objective optimization. So these are called the Connect products, and they kind of link everything else together into a connected and synchronized environment. And then connecting with the real world, we have Twin Builder, which allows us to actually link simulations to the real world, to sensors, and allows us to build these new things. You've probably heard of them, called digital twins. So this is really exciting. And then finally, obviously, to run all these very powerful tools, well, if you have a good workstation, you can run locally on your desktop. But now we also provide cloud solutions. You can run all of the Ansys products either on what's called Ansys Cloud Direct, which runs on the Microsoft platform, or you can have you can run on AWS as well. So you can run on either Azure or AWS, although the main product that Ansys handle is running on Microsoft Azure. All right, that's just an overview of the products. What I'd like to do now is to switch into new features. Now, due to the limited time, originally we said structural fluids and electronics. Unfortunately, today, given the late start and the lack of overall time, I think we're going to have to skip mostly the electronics products. But I just want to go through the discovery, mechanical, and fluids products. Now, many of the most exciting new developments are in this discovery product that I mentioned earlier. Discovery itself is actually a combination of multiple products, and it also contains parts of Ansys Mechanical and Ansys CFD. So it's a very comprehensive tool, and I say this provides the entry point to the Ansys, all of the other Ansys tools. So within the fluids capabilities, we have this new capability that we're seeing later in the demo for creating rotating fluid zones. So we can use this to simulate things like fans, pumps, stirrers, mixing tanks, all kinds of applications where we actually have something rotating and we want to see how that actually drives the flows. We have new capabilities for thermal conductance. This is important where you have thermal heat transfer between either fluids and solids or between solids and other solids, because often there are thin layers, but those layers actually provide a resistance to heat transfer. So characterizing and simulating those layers is very important to getting an accurate solution. So we have this both, as I say, on the fluid side and also on the solid to solid side. On the fluid side, we have compressible flows, time-dependent conjugate heat transfer, moving and translating walls, and we have some new GPU-based solvers. So on the structure side, we can now handle, we can do actually much more detailed structures, particularly thin wall structures that the software wasn't so strong on before. And we have a whole bunch of things for simulating bolts, different types of loads, doing topology optimization, so on. You'll be seeing some of these in the demo later. As I mentioned, we do have this electromagnetics capability in Discovery. This is mainly meant for simulating antennas, so that you might be using in wireless, wireless products. But unfortunately, we don't have time to cover that in detail in this presentation. And we have new capabilities within Discovery. It is its own CAD program. You can read in from popular CAD tools like Creo and SolidWorks and NX and CATIA, but Discovery also had its own comprehensive CAD capability. Now, this is based upon an earlier Ansys product called Spaceplane, which was well known as a direct modeler. But one of the important things now that we have in the new version of Discovery is we have parametric feature-based modeling. And this is very good when you want to do parametric type optimizations or design scopes. And also we have this new subdivisional modeling capability. So digging in a bit deeper, again, can't take too long on these. I say the really exciting thing is this new rotating fluid zone capability. So we actually define a region within the model that's rotating, and you'll see this in our demo later. And this has all sorts of uses. I mentioned this capability for heat transfer. Again, this is very important. If we want to get accurate heat transfer within complex systems, could be solid to fluid, solid to solid. But whenever thin layers, it could be, paint or coatings, linings, or even things like corrosion or fouling within pipes. All of these can affect heat transfer. For those of you working on the electronics side, this is very important when you're looking at, for instance, connecting an integrated circuit to a heat sink, because generally we're connecting through a thermal interface material, and we want to be able to look at the importance of different, the performance of different thermal interface materials. Can you just use a standard thermal pad, or do you need to go to a specialized alumina or even a silver thermal connection? On the advanced flow, we can now handle compressible flows. So we can actually model air or other gases as ideal gases. So we can actually look at the relationships between pressure, volume, temperature. So as we compress something, it gets warmer. And we can also include flows through porous materials. So for instance, in this exhaust system here, we will have high pressure pulses and a high pressure coming from the engine, but then it will go out through the catalytic converter or the muffler, and there'll be significant variations in the pressure, density, and temperature, etc. And we can now simulate these. Conjugate heat transfer we've been able to do for about a year or two now, but now we can actually do transient conjugate heat transfer. So if you're designing heat exchangers which operate in some type of transient mode, then it's very important to have this transient capability. On the structures side, as I mentioned, we're now able to handle thin wall structures with a much greater degree of accuracy. If we look back to the previous release, 2022 R2, we could see that in this thin wall structure, when we were applying a load to it, it was actually an 11% error. Now, these types of structures are very tricky, but now, in fact, in the latest 2023 R1 release, we've managed to improve the accuracy significantly. And that's in what we call explore mode. For those of you who haven't heard of the Discovery product, I just explained briefly, it operates in two modes. One is called explore and the other is called refine. In explore mode, it uses a GPU-based solver, and this will use the NVIDIA GPUs that you'll see later within the Lenovo presentation. But it uses the GPUs to get very fast, in fact, almost instantaneous results for the problem. But within that mode, the results are very fast, but there are obviously some perhaps simplifications in those. So once you've done a preliminary analysis in explore mode, you can then go through into something called refine mode. Now, in refine mode, it actually uses the very detailed analysis capabilities coming from Ansys Mechanical and Ansys Fluent. So in fact, in refine mode, you actually have Mechanical and Fluent embedded within the Discovery environment. And as you can see there, we can get a much more accurate solution. But in fact, as a preliminary design, I mean, I always reckon that if you can get an initial design within 5% of the goal, you've done pretty well. And in most cases, 10% is acceptable for design purposes. All right, so now one of the real enhancements in the latest version of Discovery is to be able to simulate reliably assemblies. Now, assemblies may be connected in various ways. They may be connected by bolts or screws. They may be connected by welds, gluing, soldering, brazing. And for all of these, what we want to know is, firstly, is our connection going to be strong enough? Are our bolts, do we have enough factor of safety on the shear stress, the tensile stress, things like that? And Discovery now allows us to actually create these bolts and other connections in a very streamlined fashion, and then to evaluate, do they actually meet the criteria? Do they have sufficient factor of safety? So we have this both for bolts. We have these detailed bolt measures for things like shear, tensile stress, and so on. And also now we can do it for these connections that these are what are called bonded connections, but they're equivalent to, say, brazing, soldering, gluing, or some types of welding. So for all of these, we can evaluate the strength of the connection and does it stay within the acceptable limits of shear and tensile stress. Another thing that I often see when people are doing structural simulations is that they simulate applications where there are, for instance, shafts or bearings which are applying a load, but they simulate them using simple distributed loads, distributed forces. Now, that works, but it can often get a very inaccurate result. So in Discovery now, we have full support for what are called bearing loads. And this allows you to simulate loads coming through shafts or bearings or other kind of cylindrical objects. It allows us to simulate those much more accurately and realistically. Topology optimization, we have new capabilities now for multiple load cases. So within a product, you may have various different types of loading upon different scenarios. You might have vertical loading, horizontal loading, transverse loading. So now you can specify all of the different types of load cases, and the software will find you the topology that meets the best, it's the best combination of those different loads. Modeling improvements, we can now, as I say, in addition to direct modeling, we can now do parametric modeling, create parametric feature-based models. And we have capabilities for subdivisional surface editing, often known as sub-D. This is something we have in Creo, but now we also have it in our Ansys Discovery environment. This is very powerful for both creating new topologies and also for manipulating, for instance, the results of a solid topology optimization. Quickly moving into Ansys Mechanical, I've just got a few minutes left, so let's look at what's new in Ansys Mechanical. In fact, the what's new in Ansys Mechanical presentation was 288 pages. but I've cut it down to about 6. So you'll appreciate I'm leaving out a lot of good stuff, but I just thought I'd mention some of the important new developments. Now, one of the things that some of you, if you've used Ansys since many years ago, you might remember that the preprocessor then was a thing called Design Modeler. Design Modeler would allow you to take CAD models and feed them into Ansys Mechanical. Now, Design Modeler was very good at doing that, but it didn't have any capability really to edit or clean or manipulate the geometry. So SpaceClaim was introduced for that, and that has now become Discovery. But one of the problems was that SpaceClaim and Discovery actually broke the link between CAD and the simulation model. But now that link has been restored through something we call GBA, or geometry-based associativity. So this means that you can actually make changes. You can read in your CAD model, you can make changes or simplifications to it within the Discovery environment. You can then go simulate it. But then if you make changes to the original CAD model, those changes can propagate through the system. So previously, as I say, that using Discovery actually broke that associativity, but now that has been restored, so you can have a complete associative link through from CAD through to your detailed simulation. Now, something else that this is enabled is the second item here. They refer to as geometry preserving adaptivity, or GPAD. One of the problems about when you do meshing on a model, you have to initially choose some mesh density. Now you can set meshes to be adaptive, so they refine themselves automatically. But the problem is they actually do the refinement based upon the initial mesh. And if the initial mesh is not good, that means that the refinement is also not good. But now the meshing adaptivity actually goes back to look at the original CAD, the original geometry from the CAD model, and it does its refinement based upon that. The third environment here is rather interesting. Now, you've probably all heard of topology optimization, but topology optimization only really applies to chunky solid objects. But you might say, okay, well, I'm using sheet metal, or even I'm using some space frame or lattice structure. How can I actually optimize that? Well, now this is what they refer to, this new capability, as topography optimization. I'm sure everybody knows that if you just have a sheet of metal, it's very flexible, it's bending and doesn't stiff. But if you want to stiffen it, you actually press in some ribs or bends or features like that, and then you can convert it from a very flexible sheet into actually a very stiff structure. But the question is, how do you actually know what's the best location to put in those stiffening features? And topography optimization actually allows you to do that, to work out the optimum stiffness given a particular amount of sheet metal material. And you can also minimize, obviously, the mass, because you can use thinner sheet metal to achieve the same level of stiffness and strength. All right, so a few more things. As everything these days has got artificial intelligence and machine learning, and of course this is an Ansys as well. But in this particular example here, it's referring to, before you actually run a simulation, you might want to know, well, how much memory on my computer is this going to take, and how long is the simulation going to take to run? And this now has got this artificial intelligence or machine learning based prediction to estimate the resources required for a mechanical simulation. Because it's no good running a simulation if a few hours later it runs out of memory. So this allows you to actually predict the memory and disk space and time requirements, things like that. New capability is also for contact modeling. This is particularly aimed, I think, at automotive customers who are doing complex seam joints between multiple layers of sheet metal. So the software now can actually generate multiple contacts on the same sheet. For instance, here we've got one sheet of metal sandwiched between two other flanges. So the software can now generate the contacts for these automatically. And finally, I don't have time to go into it, there's a lot of enhancements in mesh generation For instance, this can automatically allow you to ignore some small features but generate appropriate messages relative to the larger features. So I think I've already mentioned this, but let's just look at some examples on the screen that I'll play. So this, for instance, is looking at how the geometry preserving activity can take what is initially a very coarse and very rough mesh and refine it into a much more high quality mesh that gives us a very accurate and smooth solution. So these three examples here show the mesh refinement process in it. Moving on to fluids quickly, again, I've only got 2 minutes left, but I'll try to get through it. We have now within, I mentioned that we have a GPU solver within Discovery. We now have full GPU solver capability within Ansys CFD. So that's covering Fluent and CFX. And this doesn't just work with one GPU, it can actually run with arrays of GPUs. Now, if you get one of the high-end workstations from Lenovo, you can probably get 4 or perhaps even more GPUs all stacked up together. And now the software allows you to take advantage of these. And this is equivalent to running on thousands of CPUs. So you can get incredible performance. You know, you can simulate the most complex types of applications just using a desktop workstation with a stack of GPUs. On the physics side, we have new capabilities of simulating various tasks, I would say, within the hydrogen value chain. This is things like PEMFC, fuel cells, solid oxide fuel cells, etc. So this is all for, you know, these days a lot of interest in using hydrogen for different applications. Most of this requires simulation of different types of fuel cells. We've also now got Fluent. Got Python embedded within Fluent. So this is called PyFluent, and this allows you to actually program the Fluent environment to run complex simulations. And there are many other new features. I'll just point out a couple here. We've got this ECAD workflow, high-speed modeling, embedded parametric modeling, virtual blade model, aero optical workflow. I must admit, I don't actually know what that is. I didn't get that far in the presentation, but if somebody knows what that is, they can tell me and we can discover it together. And also there's a new ray tracing engine which can produce very nice quality visualizations. These are just some examples of the simulations done on GPUs. So these are simulations with the equivalence of tens or even hundreds of millions of cells, but they're running on GPUs on an engineering workstation. So you can have incredibly fine modeling using advanced turbulence models like LES and so on. I do just want to jump back in to mention this particular thing. Now, I mentioned earlier that within the Ansys environment, there is a specialized tool called IcePack, which can be used for detailed electronic thermal simulation. Now, those of you who might have heard of IcePack might know that, in fact, it's based upon the Fluent solver. But we often get people asking, well, I've already got the Fluent solver, so why can't I just do it in Fluent? Well, the answer is now you can with 2023 R1. So Fluent now has capabilities to do PCB and electronic component simulation. It doesn't have all of the capabilities of IcePack, but it has many of the major capabilities that people typically need to use. So say that you're a mechanical engineer, this probably contains everything you need to know. If you're a specialist electronic engineer and you also want to do, dual heating simulation, maybe you do need the full IcePack product. But now we have a very powerful capability for electronic thermal simulation within the Fluent environment. And I mentioned battery modeling there, the fuel cells, but also batteries now, lithium-ion batteries and other types of batteries. We have all that included within the software. Hydrogen, fuel cells, and so on. And again, just final thing before I hand over, we have these within the CFD environment. We have these different levels: CFD Pro, CFD Premium, CFD Enterprise. In fact, now most of the capabilities that typical users need has now been moved into the base level product, CFD Pro. So in fact, if you look at that now, You have a lot of capabilities within CFD Pro, and in fact, it's CFD Pro which is embedded within the Discovery environment. So most of the capabilities that are mentioned here for CFD Pro can actually be accessed through the Discovery environment. All right, that's my presentation.